I'm Cara Suboy, CNETnews.com. I'm here at San Francisco's Exploratorium to talk to Paul Doherty about the Phoenix lander. Paul's a senior scientist here and a planetary scientist with a degree from MIT. Thanks for joining us.
It's great to be here, and I'm really excited by this successful landing of the Phoenix lander.
Tell me about the different water properties on Mars.
On Mars, the atmospheric pressure is much less than the pressure that's squeezing in on us here on the Earth. And that makes a big difference for water. So let me can I show you about the pressures?
Please do.
So I've got this 5-foot-long steel rod that if I put it on my hand, that's the atmospheric pressure that's squeezing every inch of your body. But when we go to Mars, the atmospheric pressure on Mars is like that. It's 100 times less than the atmospheric pressure on Earth.
So to boil that water takes a lot less energy.
That's right, it takes a lot lower temperature. So for most of Mars, half of Mars, water will boil at 0 degrees Celsius, at the freezing point.
So we've got water in this test tube, and by altering the pressure, you can simulate how much is actually forcing on it in Mars' atmosphere.
So right now, the Earth's atmosphere is pushing down on this, pressing that water together so it doesn't boil at room temperature. But if I pull out on this, as you see me pulling out, I reduce the pressure, and when I snap it there a bit, when I reduce the pressure, it actually fizzes. And that fizzing is boiling, there it nicely fizzes, at room temperature.
And I hope we can see photos of that. That's sort of the plan, is that they're going to be taking pictures from the Phoenix and sending them back?
They will. We'll actually see pictures. They looked around already, and they don't see any bare, naked ice at the moment. But they have an arm with a scoop on it, and they're going to dig down into the soil, and they expect from orbital observations of different nuclei and molecules above the surface that they're going to find ice within half a meter, about 20 inches down at least. So they're going to dig, they'll expose some ice, and we'll be able to see this solid ice on Mars.
If there's ice on Mars, there's got to be snowflakes.
That's right. So I wanted to find out what's the shape of a snowflake on Mars. But on Mars in the winter, snowflakes are not made of water. They're made of dry ice, carbon dioxide ice, like on Earth. And I found out that nobody knew the shape of carbon dioxide snowflakes. So in my lab on Earth, I made a Mars atmosphere. I created a snowstorm, a Martian snowstorm, and I grew Martian snowflakes and took the picture of them.
How do they look different from an Earth snowflake?
So this is my plastic model of a Martian snowflake. It's a cube with all 4 corners on top and all 4 corners on the bottom cut off. And that's called a cuboctahedron.
Now, speaking like in the big picture, what does all of this research and exploration really mean for our space race, for what this country is doing as far as figuring out life on other planets?
Well, one of the great important philosophical questions of all time is what is life and where is life? So does life exist only on the planet Earth as we know it, or is there life elsewhere in the universe? And Mars is like the first baby step into the universe, searching for other forms of life. So we'll be there with a chemistry lab looking for ice, water ice, and liquid water, because at some times in Mars history, it can warm up at this region of Mars where we landed and make liquid water, and see if trapped within the ice, there's some sign that life exists or existed on Mars.
Great. Well, thank you very much, Paul.
Oh, good to be here.
Appreciate the demonstration. I'm Cara Suboy, CNETnews.com.